bring that into the side of it. And place it right in. There we are, proper connection. And then here's that barrel jack that we saw also on the other device. So we bring around our power, which is just connected to a regular power socket. Plug that into the back, and then you'll have a verification with that blue LED at the bottom that you are receiving power. And then on the computer, this is a different experiment. So we click on the box just to the left of my CVT. We are now running a mini dyno. And in the real world, this is the machine that people place their vehicles on. They place their cars on, and it measures the power output of their wheels, of their tires. So it's really cool to have a miniaturized version of it. So you click on Run My Dyno, and right when you click it, you'll hear a small motor sound. I'm not quite sure if that came through, but it adjusts itself, and there's that small Dirac delta on the graph, and then time progresses, but they are flat because they're not currently receiving a signal. What you need to do in order to do a signal is you can click over here on this switch that says manual or cruise control, set that to cruise control, and it will then shoot itself up to send a signal towards a goal and then simulate it on the vehicle. And so the wheels are moving proportional to the information displayed here. And it's really neat what it's doing. So it's showing the load based on if the vehicle were going up at this incline. And then as it changes, there's a little dip. It has a set amount of speed that it wants to go at, and then it has to put out that much more engine power as the incline increases, and so there's that small hiccup to where it's trying to catch up. This one's interesting. As it lowers the incline, it's aiming to go at a certain speed, and it's giving it a set amount of power. So as that incline lowers, there's a moment to where it's putting out too much power, and it has to slow down. But that little catch-up area is the part of kind of like the PID control that's being displayed here in person, in the real world. So when talking to the campers, it might be pretty neat to let them know that the scenario is, it's kind of like the cruise control in a vehicle, which most modern vehicles have. It works precisely like this, but this is a lot safer and a lot easier than going out, putting them in a car, and trying to drive up and down a mountain. Now, some funny guy's probably going to point out that, hey, you know, we should do that instead. But we can just chuckle about it and move on with the experiments. Same deal with this one in the bottom left corner. We'll have a stop button. Here we are. And then it'll bring us back to this main menu. Same scenario here. We remove the power from the experiment, and then simply pull the experiment out of the myDAQ. Okay, so we have two down. The CVT transmission experiment, the myDyno experiment, which brings us to mySolar. Now remember what I had mentioned? There's a solar bit right here, and it's going to scan using this servo the light source and then report that on the screen. Same process. Now the only thing different here is that it does not require the extra power jack. Everything you need is already built in, and it will receive its power from the input of the myDAQ. And put that back over here. Piece this together. There we are. And same here, as soon as it receives some signal, it might move around a little, but it's nothing to be concerned about. So on the software, same process as we've run myCVT, as we've run myDyno, we're now going to run mySolar. And as we clicked it, we have this meter here showing representing light intensity that's reaching the panel itself. And this panel position goes from 0 to 100. And as that slider moves, that's going to represent where the servo is pointing the solar bit. So as I increase this, and as I move it left and right, it too is moving the servo. And it's also making a representation of when it's at a certain point, this is the intensity of light that it's receiving at that angle. So it's making this graph, this data plot points of information based on the intensity of the light in that direction. So that's really cool to do manually, but you can also do an auto sweep. And the auto sweep will step through automatically and plot what it finds. There we are. It's slowly scanning the area. And if you can see the curve on the graph, that dip represents that when it turns at that angle, the efficiency lowers if it were receiving a mass amount of power. Here we are. So one neat representation that could be done is if any of the extra campers have a cell phone with an LED flashlight on it, they can turn on the modified light and they'll see a difference on the graph as it comes closer to that area. There will be a spike in the light intensity. So if we placed it about here, let's remove it, see, and then place it there, and it'll jump up, and it did so immediately. So that'll be a real neat experiment also to show that kind of gets away from the mechanical aspect of judging power versus efficiency. And this one has a little more of a focus on renewable energy, which is always welcomed in engineering circles and talks. Alrighty, and when we're done there, this too has a stop button in the bottom left corner, as well as on here. And that'll be concluding the National Instruments experimentation. All of this can simply be closed out with the X's. You'll receive these dialog boxes, and what I'd want you to choose is there will be a checkbox for apply same action to the remaining such and such affected items. Make sure that is checked and go to don't save all. And that'll just leave everything as it was from the get-go, unmodified. We can close. There we are. All right, guys. Thank you for listening.